Alright guys, so today I just want to talk about the simple final for Algebra 2. Okay, so some of the questions that I just want to talk about here. So you probably want to take notes and also just follow through the problem that I'm showing you here in a minute. Okay, so first of all, things I need to know recently, so things that we talk about, sequences and series. So we do know that, well, let's say that we have A1 equals 14 and the common difference is 3. And then n is 7. And this one you want to find out the number of the 7 terms. And also you want to find the sum. Okay, so anytime they see something like this, so that means we're using a formula. So for the arithmetic series or the sequence, so we do have A1 plus quantity of n minus 1 times the common difference. So for A1 here, so we got 14, n, which is 7, minus 1, common difference, so 3. So that means the rest of this is all about pandas. So 14 plus 6 times 3, 18. So 14 plus 18, which is what? 32. So that's the number of the 7 terms. And then what about the way to find out the sum of the entire sequence from the first term to the 7th term? So the way to do it is by using n over 2 times the quantity of A1 plus A sub 7. So n, which is 7, so 7 over 2. A sub 1 is 14, and then A sub 7, the one that we just found, which is 32. So 7 over 2, and then 14 plus 32, which is 46. Reduce, cross cancel, so we do have 23 times 7. So 7 times 3, that's 21. 2 times 7, 14 plus 2, so 161. So the way to find the sum, and also the way to find out the number of the term of the arithmetic sequence. And now, what about for anything that's considered geometric? So let's say we have a geometric sequence. So we do have A1 equals negative 3. Common ratio, that's 5. And it's 7. Again, this one you want to find out the sum. So the way to find out the sum for this, we're using the formula n over 2. Well, let's see. It's actually A1, because that's geometric. Well, the reason why I know that's geometric because that involves the common ratio, not the common difference. So this one's the common difference. The previous one that we did. So the way to find out, well, the sum is by using the formula A1 or A sub 1 times the common ratio to the power of n minus 1 over r minus 1, the whole quantity. So A1, negative 3, common ratio 5 to the power of 7 minus 1 over, and then 5 minus 1. So this one's a big number, so you need to multiply it 7 consecutive times. So try to finish that. It's all about pandas. And let's see what else I need to know. Rational, expression, addition or subtraction. So let's say we do have a problem like 3v over 2v minus 3 minus 2v and then v minus 3. So basically this one you want to find the least common denominator. So since they have nothing in common, so that means the least common denominator would be 2v minus 3 and then v minus 3. And then in order to go from here to here, so you need to multiply top and bottom by v minus 3. Over here, again, 2v minus 3, that's missing, so we need to multiply the missing element, top and bottom. So distribute, so v times 3v, so we do have 3v squared minus 3 times 3v minus 9v. Negative 2v times 2v, so negative 4v squared. Negative 2v times negative 3, then that would be considered positive 6v. Again, it's the same denominator, that's why we can put this all together. And then combine the like terms. So 3v squared minus 4v squared, negative v squared. Negative 9v plus 6v, negative 3. And then denominator, just leave it. And perhaps you might want to factor the top part, so take out the negative v, the greatest common factor. So we do have v plus 3. Well, the reason why I need to factor it, because that's the greatest common factor, and not a purpose, because sometimes you can find out things you can reduce. But there's nothing you can reduce at this moment, so just leave it. So then that'll be the final. And now let's see what else that we have. Also rational expression, but this time it's considered division. So rational expression division, so that means we need to flip something over. And also we need to do some factoring. Again, factoring is playing the big part of Algebra 2. So let's say we get 9k squared plus 81k over k squared plus 6k minus 40 divided by 10 over k minus 4. So this one is division. So the first thing that you want to do, you want to factor it. So 9k squared, 81k, so we take out the greatest common factor. So this one is 9k, greatest common factor. So we do have k plus 9. Denominator, we try to factor it, so negative 40. So this one looks like it's considered 10 and negative 4. So k plus 10, k minus 4. Divided, that means we need to convert that to the reciprocal. So it's k minus 4 over 10. As you can see that here, so k minus 4, common binomial, cross cancel. And anything else that we can cancel here. 9, 10, nothing common. K, there's no k here. Binomial, different binomial, inconsistent, nothing we can cross cancel. So that means for the rest of this, we just want to bring it down. So it's 9k times k plus 9 over k plus 10. And then don't forget about that 10 right here. It's the greatest common factor. So that would be the final one. Okay, so now let's see what else that you need to know. So things that we talked about recently and things that you guys were struggling before. Make sure that you know how to simplify the exponents, the properties of exponents. That's very important. And now let's do the one that's considered rationalizing with the radical. So that's one of the sections from chapter 7. So let's say we do have something like 6 over 2 minus root 3. So that means we want to multiply by the conjugate of the denominator, 2 plus root 3. Again, this one is just a simple question. It's not the exact same thing as the final, but they're pretty similar. So the conjugate, multiplied by the conjugate, that means the difference of 2 squares. So we do have 4 minus 3. Again, this one is like a minus b times a plus b. So it's like a squared minus b squared. So 4 minus 3, the top part right here. So 6 times 2, so we got 12 plus 6 root 3. So 4 minus 3, that's 1, so that means the denominator is 1. Nothing you need to rewrite. But the top part, so we got 12 plus 6 root 3. That's the final form. Okay, so now let's do the one with the radical again, but this one is about simplifying the radical. And also things that we can combine, subtract, or cancel. So let's say that we have negative root 27 minus, let's say this one is 2 root 3, and then plus 3 root 18. So 27 is a non-perfect square number, so we want to break it apart. So we got 9 and 3. Negative, bring it down. Negative 2 root 3, nothing we can do about it at this moment. Bring it down. 18, so we do have 9 and 2. Again, we want to break it apart into perfect square number and the non-perfect square number. So square root of 9, then that's 3, so negative 3 root 3 minus 2 root 3. Over here, root 9, again, so it's 3. But don't forget, there's a 3 outside the radical, so we multiply it, so it's 9 root 2. Now we want to find out the common term, or the similar term. So it looks like the first term and the second term, because that they're both under the same radical, same bracket. So negative 3 root 3 minus 2 root 3, so we do have negative 5 root 3. This one's a different radical, so nothing we can combine. Bring it down. And then that'll be the final form. Okay, so another one that you need to know, it's about another simplifying radical. So mainly the second part of the final is pretty much like the second half of Algebra 2, like the second semester, all the stuff that you learned from chapter 6. So here's another one. So we do have negative 5, and then square root of 490, x to the power of 6, and then y to the power of 5. Well, this one is considered square root. Okay, so the negative 5 is just the leading coefficient. So negative 5, nothing we can do about it. Again, 490, non-perfect square number. So you want to break it apart. And then for the rest of the variable, you can always convert it back to the exponential form. So one thing that we notice, so n root of a to the power of n is the same as what? A to the power of m over n. So for the variable, this one is written as 6 to the power of 6 over 2. And then y to the power of 5 over 2. Alright? So again, 490, non-perfect square number, break it apart, so we do have 49 and 10. Again, negative 5, just bring it down first. So now let's try to simplify this. So negative 5 times root 49, then that'll be 7. Root 10, just leave it like this. And then 6 over 2, then that'll be what? To the power of 3. And this one is in improper fractions. We can always convert it to the mixed number. So that one is written as 2 and 1/2. So anything that goes outside of radicals, so we do have negative 5 times 7, which is negative 35. What else goes outside of radical? X to the power of 3. And then things that we have, hey Paul, y squared. I'm just doing the YouTube video right now. Sorry. You done already?
Yeah. Here we go. I'm going to bounce this thing.
Yeah,
Thank you.
just leave it right. Okay, so going back to the problem here, so what we got is x to the power of 3, and then y squared. Again, things that's under the radicals, so we do have 10, and then y. Again, non-radical number, or the non-perfect square number, and the other one with the rational exponent. So everything else, so just leave it, and that's the final form. Okay, so now let's see what else that we have for the rest of the problem here. Okay, so give me one sec. Another one that you need to know, it's about solving. There's so many solving equation problem here. Radical, with the rational exponent, quadratic, and also polynomial. So now let's take a look at some of the problems real quick. So for the next one, what we got here, so we do have b plus 2. So that equals square root of 4b minus 7. So now, the way to solve for this, okay, so b plus 2. We do have a radical on the right-hand side, so that means we want to take the square of both sides first. So we got b plus 2 quantity squared. So that equals 4b minus 2. The radical with the exponent, pretty much they both got canceled, because that's like 2 over 2. And then over here we need to expand it, so it's b squared. If you don't know how to expand it, you can always FOIL it. So b squared plus 4b plus 4. And then 4b minus 2. So things that they share in common on both sides, we can cancel them out. 4b, 4b. And then we got b squared. So that equals negative 2 minus 4. And that would be negative 6. And now you might be wondering, how do we solve for this? Well, basically that's just taking the square root. And for the square root of a negative number, so that would be considered imaginary. So it's a quadratic, so it's plus minus root 6 I. Again, square root of negative 1, that's considered I. Imaginary number. So we need to separate the imaginary number with the real number. And then b, just bring it down. That's it. And also make sure that you know how to solve for the quadratic equations, the formula for factoring, quadratic formula, and also the way to complete the square, and also using the factoring pattern. Okay, so those are something that you need to know. Combine like terms, that's something you guys are pretty familiar with. And let's see what else, synthetic division. Okay, so let's do one problem for synthetic division. Synthetic division, so here's what we got. So we got r to the power of 3 plus 2r squared plus 2r minus 10. And then divided by r minus 3. So synthetic division, that means you need to write down all the coefficients. For the dividend, so we do have 1, 2, 2, negative 10. divisor that we have is always the conjugate of this, so it's positive 3. First number, we don't do anything about it, bring it down, so it's 1. And then 1 times 3, so we do have 3 plus 2, so we got 5 here. 5 times 3, that's what, 15? 15 plus 2, 17. 17 times 3, and then we do have 51. And then plus negative 10, that means the final remainder will be considered 41. And then the way to rewrite it, so again, anytime that you divide it, so that means the power, it's always reduced down by 1 degree. One thing that we notice, r to the power of 3 over r to the first power, it's r squared. So that means the first number, you started with 1r squared, and then the rest of this is always descending order. So it's 5r plus 17, so it's a trinomial. And now what about the remainder? The remainder, you want to put it as 41 over the divisor, r minus 3. That would be the final form for the synthetic division. Now what happens for those of you who don't like the synthetic division? You can use the long division. But that's going to be a lot more work. It's going to be a lot more tedious. Okay, so now let's see what else that we have. Inverses. A lot of people still having a hard time with inverses, finding the trig functions, the inverse of logarithmic functions. So here's one of the problems. So the way to find an inverse. So let's say we have y equals log base 1/4, and then x minus 4. So first thing that you want to do is swap the variable, switch the variable. So x equals log base 1/4, and then y minus 4. And now it looks like nothing we can do at this moment, but we need to find out a way to isolate y by itself. So the base is 1/4, the power, which is x. And then the result, y minus 4. So one more step that we need to finish with this. So base 1/4 to the power of x, f4 on both sides. Now y, we already use that, so we need to apply the inverse notation, inverse of f of x. So we just turned down the log functions to an exponential function. And guess what kind of exponential function this one is? That's right, exponential decay. Okay, so now let's see what else that I need to cover for this. And make sure that you guys know what to do with probability, things that we talked about recently. And also, the one that we talked about, it's the sequences in series. We talked about those earlier. And make sure that you know the properties of logarithm, the last test that we did before the final. Solving equations, solving rational functions, rational equations. Okay? So those are the ones very important. So anytime that you're kind of getting struggled or getting stuck with a certain problem, you can always go back, either rewind or fast forward. Okay, so thank you for watching the video today.